process control block, all those things. So we have two more topics remaining. One is operations and process, which we'll try to see today. Then next topic is something like inter-process communication. Then after that, we have a example of real-time example of how the process is going to be done. I hope my voice is clear to everybody.
Yes, sir.
Yes.
Fine. So whenever we create a process, we know what is the process. We have well understood what is the process. Process is some work done by a computer. We have repeated that for many number of classes as well, right? Remember what is the process, everybody?
Yes.
Yes, sir.
Yeah, process is a work which is going to be executed or which is going to be done or which is going to be compiled by a computer. Now, when we come to this process, the process will be created, okay? The process will be executed, the process will be terminated, okay? That is what we know. So what is a mechanism for process creation? What is the mechanism for process termination? That is what we are going to mainly concentrate on the topics. Okay. So what is the mechanism for process creation and what is the mechanism for process termination? So when we come to the process state, we have seen 5 different states of a process. First one was creating a process new, ready. Okay. Then what is the next one?
Running,
Running, good.
waiting,
Waiting.
terminated.
So when creating a process, okay, or when terminating a process, what is the mechanism? First, we'll see the mechanism for process creation. Okay. Fine. So here, everybody know that we are creating a process. Suppose I'm compiling a program, the process is going to be created. Okay. Now, for that process, we have one more new term called as child process or children process. What is this? We'll see first. Okay. Here, this is nothing but suppose you might have worked on with something like data structures, DBMS and data structures and C++ program in the previous semesters. Yes or no?
Yes, sir.
Fine.
Yes, sir.
Just a simple example I'll give you. I have written a program in C++ and from C++ program, I am opening a file. Remember, we used to open a file from yes, no.
Sir, your voice is not audible.
Sir, unable to hear your voice.
Now,
Okay.
Okay, sir.
But low, sir.
now it is audible, ma?
Very low, sir.
Fine. Now, so when we come to this process exactly, Here, what we are trying to do is we are creating a sub-process for the main process. So what is that? How to create a sub-process? Here, when we take these things exactly, what will happen is, suppose you are doing a program in data structures. Especially if we come to something like linked list. There, what is happening? The data is going to be stored in the form of links. Along with the links, the data is going to be stored. Remember that program everybody list? Are you able to remember the programs of linked list or at least C++ program, opening and closing of files? Yes, no, somebody answer me.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. So in C++, if you take C++, what we are doing from a program, we are opening another file, right?
Yes, sir.
Yes or no? Even we have done the program for the lab also. Opening a file, closing a file from C++.
Yes, sir.
Yeah. There,
Yes,
what
sir.
is happening is, for running a C++, we require process. Again, inside the program, I have to open a file. Opening a file is also work done by a computer. Yes or no? Opening a file is also a work to be done by a computer. So again, for opening a file, I need another process. So here, if we take the process, the main process is C++ program which we have executed. And internally, another process, the same process is from C++, I'm opening a file. So for the main process, I'm creating a sub-process. Remember, clear? So
Yes,
like
sir.
this, we have some
Yes, sir.
concept called as parent process, for which we are creating a children process. Parent process, creating a children process, that is, which in turn creates other process. Main process is creating a sub process. Okay, I'll show you a diagram here. This is the main process. Process ID is 1. Here the process ID is 1. For this, we have 3 sub-processes. One is login, one is thread, one is SSH schedule. Again, they have different process IDs. This process has separate process IDs. Again, for this process, we have some sub-processes. Okay, with different process number. So one process creating a child process. Again, that process is creating another child process. That process is creating another child process. Like this, we can create n number of child processes. We can create n number of. Or if we take second process, it is having only one child process. Again, if you take third child process, it is having 2 sub child processes. So like this, to one process, we can create n number of child processes. So they are called as parent process is creating a children process. And generally the process is identified and managed by using something called as process identifier, PID. Every process is having a unique process ID. Yes or no? In process control block, we have seen process number, process rate, process counter. Yes or no? So every process is having a process number, process ID. And what about the resources? When a parent process is executing, the child process will share all the resources of the parent. What do you mean by resource here? I've explained you many times what is a resource. What are resources of WhatsApp?
Contacts, messaging,
Contacts,
video,
audio support, video support, all these things are resources. So if we take Zoom, what are resources of Zoom?
video, audio.
Video, audio, okay, all kind of graphical things. So when a parent process is having a resource,
Audio.
yes, yeah. when a parent process is having a resource, that process can be also shared by the child process. That's the first thing. Then children process share subsets of parent resources. Same point once again. So children process will be subsets of parent. As math students will be understand the term subset very much. Parent and child share no resources. Okay, so there will be three options. There will be three options. First one is parent and child shares all the resources. Second one is children share subset of parent. Subset means only few of them. Then parent and child can share no resources. Depends on the process that is executing. Depending on the process that is executing, any of these three options can work. They can share the resource, they can share only a few resources, or they can share no resources at all. That depends on a program completely. Okay. Now, coming to the execution option. Parent and children execute concurrently, means at the same time. Next option is parent has to wait for the child to get executed and terminate. So it depends. Again, it depends on the process. The parent and child will execute simultaneously and complete the execution. Otherwise, the parent process has to wait for the child process to get completed. So there can be any of these options. While sharing the resources, we have three options. While executing, we have two options. Here, as I have shown, these are simple example of a process creation. Okay, how it happens. Normally, process creation will be in the form of a structure of a tree. You might have seen the hierarchical inheritance. Remember hierarchical inheritance in C++? In Java also. So it is of similar nature. Okay. Now, next thing. Address of a child and a parent process. Child is take some time to duplicate address of the parent. That is first option. Second option is child will have a separate address space. Address is something, but I'm talking about the storage space and execution. Okay. Then next thing, when a process has to be executed, it takes few functions. Fork is one of the function which we have seen in Unix. If you remember, in the previous chapter, we have seen functions. Fork, exec for execution. Okay. So especially in Unix, fork is a function which will create a new process, which will create a system call. It is a system call for a new process. If you remember, these are all the system calls. We have a list of many system calls in the previous chapter. We have system calls for Windows, system calls for Unix or Linux. Then we have one more function called as exec, execute, which is used after fork to replace the memory of the program, to replace the memory or process of a program. So first, if you see the example here, fork function which is called, for which a child process is created, the parent process, and child process is created. And for the child process to execute, we are using a function exec. That is, exec function is used after fork to replace the memory of a process. Then once it is executed, it is going to exit, that is terminate. Then once the child process is terminated, then parent process will continue its execution. Clear? This is a sample from I shared with you later. Then we have one more thing called as process termination. How process termination occurs for the child and parent. Process executes last statement and operation system to delete it. So normally the process, once it is completed, we use the function exit. Exit is the function which is going to terminate the program. If a process has to wait, if a parent process has to wait for the child, then the function is wait. These are all the normal terms. Right? Then process resources are deallocated by operating system once it is terminated. Whatever the resources, like if we use WhatsApp we are using audio and video. So if I receive a phone call, video and audio will be enabled. Once the call is ended, audio and video will have to be released. So that is what is called as deallocation. Okay, following me, everybody.
Yes, sir.
Yes, sir.
Then what we have is parent
Yes,
can
sir.
terminate execution of a child process. Suppose the parent process feels that it has to close the child process, then it uses a function called as abort. When it will do that, child has exceeded allocated resources. That is, child is taking lot of resources. The task assigned to child is no longer required. That is, the child process completed, but it is not terminated. So it can abort. Parent process has the capacity to close the child process. The parent is existing and some operating system do not allow child to continue if parents terminate. That is, parent is closing, but child is not closed. So automatically the child also will be closed. So these are things that we have in process creation and process termination. Waiting for termination returns the process ID. Okay, that is when the termination is going to happen, it has to return the process ID. Okay, if no parent is waiting, the terminated process is zoomed. Zoomed means it is closed. If parent terminated, process are orphans. Orphans means if there are no parent process, child process has to be terminated. If it is not terminated, then the process is called as orphans. Clear with this, everybody?
Yes, sir.
So there we have process creation and process termination. Two things we have in operations of process. Clear, ma?